Happy weekend! Let's graph. Today we're using intercepts. The essential question is, how can finding the x and y-intercepts of an equation help me graph that equation? We're going to use something called the intercepts method. Now, when I think of the term intercept, I think of interception, which makes me think of American football, and specifically this play. This was in the Super Bowl a couple years ago. The Seattle Seahawks were driving down the field. They made it to like the 1-yard line. They were about to score a touchdown right at the end of the game to win the game, but they threw an interception to the other team, meaning this guy caught the football instead of this guy. He picked it off, as they say in America. That's not really what intercept means in math, but it's sort of similar. Like the pass was going here, and this guy intercepted it right there. So intercept means like where something crosses. In this case, the player crossed with the ball, and so he caught it. In a graph, it's going to be where the graph of the line crosses either the that's the y-axis, or the x-axis. So we're going to see where the graph crosses either of these axes and use that to graph. Intercepts method is a very easy way of graphing. So let's take a look at 2x plus 6y equals 12. We're going to graph the line, then we're going to give two other points on the line based on the graph. So let's look at 2x plus 6y equals 12. Hopefully you've figured out by now that an equation of a line is like all of these x and y points that work in the line. So any x and y that I can plug in that make the equation true, that's going to be on the line. So let's, for instance, pick any random number we want to plug in and solve for the other variable. I think plugging in 0 for x would be an easy thing to do, right? Let's think about what happens when I plug in 0 for x. Well, 2 times 0 plus 6y equals 12. What's 2 times 0? Oh, it's just 0. So in other words, this whole term goes away because 2 times 0 is 0, and I'm left with just 6y equals 12. At this point, it's easy to solve for y. You can just divide both sides by 6 to get y equals 2. So I know that when I plug in 0, the y needs to be 2. And I found an intercept. That point is actually a point on the line, and it happens to be the y-intercept. If I graph this over 0 up 2, that's right here. Let's find the other intercept, and you may have guessed to find the other intercept I can plug in 0 for y, because remember, I'm just trying to find any points that work on this line. If I plug in 0 for y, let's think about what will happen. I have 2x plus 6 times 0 equals 12. What happens to this term? What's 6 times 0? Oh, it's 0. And 2x plus 0 is just 2x. So I have 2x equals 12. This whole term goes away. And I can easily figure out that x equals 6. So when I plug in a y of 0, the x has to be 6. And this is the x-intercept. If I plot it over 6, up 0 would be right here, I think. What did I do? I plugged in 0 for x and found what the y equals. Then I plugged in 0 for y and found what the x equals, and that gave me 2 points. As long as I have 2 points, I can easily graph this line. Let me try to make it as straight as possible. I somewhat succeeded. Now, in the problem, they also ask me to give 2 other points on the line. I could do this by guess and check. I could also make a table, but let's look at the graph. Let's look at where I see another point on the graph. I have a bunch of other points, right? Every single point in this line is one that works on an equation, in the equation, but some of them are easier than others. For example, look at this point. Do you see how it's right on the intersection of 2 grid lines? This is the point over 3 up 1. Let's see if that works in the equation. If I plug in 3 for the x and 1 for the y, I want to see, does that equal 12? Let's find out. Well, 2 times 3 is 6, 6 times 1 is 6. Hey, it does equal 12. Nice. And that makes so much sense. It's a point on the line, so it should make the equation true, and when we plug it in, it actually does. Let's find another point that's on a perfect grid line. Here's a point right here. This is the point over -3 up 3. Let's plug this point in and see if it works. So let me erase my work here. We're now plugging in, for the x, we're plugging in -3. For the y, we're plugging in 3. Let's see if it equals 12. So 2 times -3 is -6. 6 times 3 is 18. -6 plus 18, yeah, it's 12. So it does work. And again, it's a point on the line, so it should work in the equation, and it does. Let's do one more example. This is a pretty simple topic. I want to graph x minus 3y equals -9. Again, I'm going to use intercept method. And remember, the main idea with the intercept method is I want to plug in the easiest possible value for x and y. So if I plug in 0 for x, let's see what y equals, and that will give me the y-intercept. Plugging in 0 for x, remember, makes this term go away because I've plugged in 0 for x, and 0 minus 3y leaves me with just 3y. At this point, I can very easily solve by dividing both sides by -3. That will leave me with y equals -9 divided by -3 is 3. So when x is 0, y is going to equal 3. And let's go ahead and plot that point. Over 0 up 3, there's the y-intercept. Also, I can plug in 0 for y. When I plug in 0 for y, remember this whole term goes away because -3 times 0 is 0, and x plus 0 is just x. And here, no solving required, x equals -9. It just tells me straight up, I don't need to solve anything, I just have x equals -9. Let's plot this point, over -9 up 0. Oof, here's my line, and I'm just gonna draw little points to make it easier. Okay, so here's my line. Here's another one where it says find 2 points on the line. Let's pick 2 points that look good. This one looks right on the line, and this one looks right on the line. I know it's not perfectly straight. If you use a ruler, you should be able to easily see where the intersections are. This point, this is over -6 up 1. Let's just make sure it works in the equation. Remember, to make sure it works in the equation, I'm going to plug in -6 for x. We'll do that down here. -6 minus 3 times, I'm plugging in 1 for y. Does that equal -9? Well, look, -3 times 1 is -3, and -6 minus 3 is -9. Word up, I got it, yay. Here's another point, that's over -3 up 2. Let's make sure that equals -9, and then I'll stop embarrassing myself by saying things like word up and end the video. So with this one, let's see, I'm plugging in -3 for x, that's exciting, and then -3 times 2 for y, thrilling, and I'm trying to see if this is equal to -9. Okay, -3 times 2 is -6. Hey, -3 minus 6 is -9. It does equal what I think it should. And again, it makes sense. Any point that you could possibly pick on that line is going to work in the equation, even ones that involve decimals. Hey, that's all I have for you today. Just a summary. To find the intercepts, plug 0 in for x and solve for the y. That'll give you 1 point, the x-intercept, 0, comma, something. Then you can plug in 0 for the y and solve for x. That'll give you something, comma, 0, and that'll be the x-intercept. So if I find those 2 intercepts, I'll be able to plot the graph. Just a reminder too, I don't know if I made this super clear in the video. Remember, the x-intercept is where the graph hits the x-axis. So this is the x-intercept. And the y-intercept is where the graph hits the y-axis. So this would be the y-intercept. So just in case that wasn't clear in the video, there it is for you. And that's all.